Hi, Doctor. My name is Wong Ching Kang. Can call me CK. My entry number is AE180110. Today, I will represent my group to do the presentation for the experiment at over headline model. And now I will present for the activity 1, which is the no-look performance. Okay. Before I start my presentation for the activity 1, I would like to introduce some equipment. Okay, the equipment that we use in this experiment, which is the first one is a three-phase supply, and the second one is the power circuit breaker, and this one is the three-phase transformer, and this one and the last one is three-phase measurement meter, and the last one, this one is the overhead line model. And we assemble the circuit, connect the circuit according to the lab sheet given, the diagram in the lab sheet given, and we use the red color to represent the red phase, and the yellow color for the yellow phase, and the blue color for the blue phase, and the yellow color for the neutral. And we apply the voltage to 380 volt, and we use the three-phase measurement meter to get the result. Okay, from the three-phase measurement meter, we get the result, which is the U1 line to line is 336 volt, and the U2 line to line, which is 520 watt, and the P, which is 2.8 watt, and the last one Q is the negative 66.8 watt. And this is the for the activity 1. And now I will do the presentation for the activity 2, which is concept of operating capacitor. Okay, and in this in activity 2, we just add these two, which is the line capacitor to the circuit, and we assemble according to the lab sheet given, and we set the primary side of three-phase transformer in delta connection 380 volt, and using bridge plug to set the secondary side to star UN negative 10, which is 10%, and we remove all bridging plug connecting the capacitance to line model. Connect the electrical line capacitance to the beginning and the end of the line model. And the last is the supply voltage we set to the 380 volt, and we measure the voltage between the other conductor at the beginning and end of each line capacitor, as well as the reactive power consumed by the phase, and we get the data from these two, the three-phase measurement. Okay, and we get the first line to line is 340 volt, and the second is the two line to line is 450 volt, and the last one is the Q is equal to negative 66.5 watt. That's all for my presentation for the activity 2. And now I will do the presentation for the activity 3, which is line with increased operating capacitance. Okay, all the circuits is almost the same. And now we just do some adjustment, which is connecting the two artificial line capacitance. The operating capacitance of the line are double, and voltage increase affect the line end is truth amplified. The supply voltage is set to UN equal to 380 volt, and we will get the measurement, which is at the which is from the three-phase measurement meter, and we will get the data, which is U1 equal to 340 volt, U2 is 302 volt, and the last one Q is negative 147 watt. That's all for my presentation for activity 1 to activity 3, and my group member will continue to present for the activity 4 and activity 5. Thank you.
Assalamualaikum. My name is Sharifah Nafrana binti Said Yusof. In this video, I will do activity 4 and activity 5. So first of all, for activity 4, which is ohmic inductive load, all we need is a three-phase power supply, power circuit breaker, three-phase transformer, transmission line, transmission line model, 2 unit of 3-phase meter measurement, resistive load and inductive load. With the 3-phase meter measurement, we can calculate the measurement for sending end voltage and receiving end voltage. We can calculate the voltage measurement, current measurement, power, real power, apparent power, reactive power, and also power factor. So now I will do the connection. So I'm using red, yellow, blue and black to indicate the phase. Okay, so let's do the connection. Okay, so after finish with all the connection, we are going to switch on the 3-phase power supply, the circuit breaker, and we set the resistive load to 3 and the inductive load to 4. And then at the sending receiving end, we are going to calculate the measurement for U1, I1, P1 and Q1, and at the receiving end voltage, we are going at the receiving end meter, we are going to calculate the U2, I2, P2 and also Q2 and also the power factor. So to get the measurement for U1, we push the U button here and we will get the measurement, and same goes to all other measurement. And then we change the resistive load to 5 and the inductive load remain the same, and we take again the measurement. Repeat the same step, but this time we are going to change the inductive load to 6 and resistive load back to 3. And we are going to take the measurement, and then we are going to change the resistive load to 5 and the inductive load remain the same at 5, and we are going to take the measurement. Then change the inductive load at 6 and resistive load back to 3, and we are going to take the measurement and repeat the same step. Change the resistive load to 5 and inductive load remain the same at 6, and we are going to take the measurement. The last one is we are going to remove the resistive load here, so we are going to unplug this wire, this 3 wire here, and change the inductive load to 4, and we are going to take the measurement according to table 8.4. Okay, that's all for activity 4. Thank you. Okay, now let's move on to activity 5, which is ohmic capacitive load. For activity 5, it is the same as activity 4. We just need to change the inductive load to capacitive load, since you are going to measure based on the capacitance value. So let's do the connection. I'm using red, yellow, blue and black to indicate the phase. Okay, now we are finished with the connection. We are going to switch on the power supply, the circuit breaker, and we set the resistive load here to 3 and the capacitive load to 1, and we take the measurement. And then we are going to change the resistive load to 4 and the capacitive load is remain the same at 1, and we are going to take the measurement at the sending end and receiving end voltage. Next, we change the capacitive load to 2 and resistive load back to 1. All the capacitive and resistive load are going to change, and we are going to take the measurement. Then we change the capacitive load to 2 and resistive load to 4, and we are going to take the measurement. Then after that, we are repeat the same step, but we are changing the capacitive load to 3 and resistive load back to 3, and we are going to take the measurement. And then we are going to change back the resistive load to 4 and the capacitive load remain the same for the 3 capacitance. And we are going to take the measurement. And the last one is we are going to remove the resistive load here. We need to unplug all these 3 wires and let the capacitive load to 3 at 3, and we take the measurement at the sending end and receiving end. Okay, that's all for activity 5, and that's all from me. Thank you.